Right. Okay, the reviewer has the floor. Please use the mic.
Hello, my name is Jun Dong, and I'm the reviewer of this debate. I think the discussion that went on was very heated and was very enjoyable. And I would first like to summarize the flow of the report. So the first thing he was make a theoretical model, and he did a rigid body assumption with non-inertial reference frame. And also he considered friction and the motion of the liquid. For the experiment, he experimented on velocity, acceleration, and the time of the bottle. And also he included parameters such as the volume ratio, radius, and the viscosity of the fluid. And in conclusion, he said that with the rocking bottle, and he said that his analogy was valid when the volume is under 50%, and also the effective parameters were valid also. So his conclusion overall was that volume affects the center of mass, radius affects the period of oscillation, and viscosity affects the damping factor. So to summarize the strengths and weaknesses of the reporter, he used good and simple experimental setups such as the slants. And also, he suggested various appropriate models for the phenomenon, also suggested conditions when they were not applied, and also he used concrete mathematical equations to support his theoretical analysis. However, I thought there were some weaknesses. First of all, there was a lack of controlling errors or variations concerning the slant slope, which the opposition also pointed out, and he failed to include the rocking motion, stopping of the oscillation, the horizontal oscillation. Moreover, he calculated the water surface as linear, when there could have been other possibilities also. For the opposition, he had a strong, confident voice and posed many central questions relating to the problem, and also mentioned the problem of controlling initial velocity. For his weakness, he was somewhat too fierce in the debate. He could have given some more suggestions, and he sometimes focused a little bit too narrowly on the interpretation of data. For the points of discussion, these are they discussed about the validity of the theoretical model, the rigid body assumption, the mechanics of the rocking bottle, experimental setup, such as the slants, and also the interpretation of data, and finally a little bit about the horizontal oscillation. So, for the points that I thought could be improved was, first of all, they had a weakness in applying shear stress. They both answered that dynamic viscosity would have been a better factor in measuring the friction between the liquid and the bottle. However, kinematic viscosity could also have been a possibility. Moreover, they could have explored more in detail about the horizontal oscillation, which is also relevant to this question. Finally, I think it would have been better because they modeled their theory as a rigid body assumption, that if they could have had done a reference experiment with an actual rigid body, and it would have been helpful in supporting their assumption. So overall, however, I think this was a very enjoyable physics fight, and I thank you both, the reporter and the opponent, for having such a good discussion. Thank you very much.
Okay, the reporter team, you have 2 minutes for your final concluding remarks. Please begin.
So, it was a fruitful discussion, and I really enjoyed this discussion. At first, I met the rocking bottle problem. Rocking bottle problem. It was very hard to interpret the phenomenon because it was the motion of the fluid that is not in a certain pipe or in static equilibrium, but rather in moving cylinder. However, by assuming that the liquefied is actually a rigid body, and showing that the rigid body assumption can hold when the volume of the liquid is under 50%, I could effectively predict the experimental results. And there was some argument about that walking bottle phenomenon actually means that the oscillation of the bottle before just stopping, but however, to me, the walking bottle phenomenon at the initial stage was more interesting, and the oscillation before stopping happened to occur and not occur according to the situation when in which you actually get the perfect horizontal surface or not. So overall, solving this problem, I went through many conflicts and I solved it, and it was a very exciting experience. Thank you very much.
Okay, I thank all three teams for a wonderful discussion. Now, the members of the jury will take a couple of minutes to ask very easy questions for all three
There is a
teams.
slide before the equation. Full sideways. What is F prime there?
F prime, the F prime is the frictional force between the horizontal surface and the bottle. And inside this frictional surface, because in my observation of the phenomenon, the translational distance the bottle traveled was almost consistent to the radius of the bottle times the angular
So in the
displacement.
equation of motion, you included that force,
Yeah,
frictional force, in the translational motion and rotational motion.
yeah.
So the cylinder is moving to the left in this case,
In this situation, the cylinder is accelerating to the right.
to the right,
Yes.
and the frictional force is acting in the direction of motion.
So the frictional force happens. So when you accelerate any cylindrical object that will do the smooth rolling motion, there will be frictional force between the surface and the contact
So
point.
the frictional force is accelerating the cylinder.
So it is actually the frictional force actually happens to harmonize the translational acceleration and rotational acceleration. So according to the magnitude of the translational acceleration and angular acceleration, it's caused by these two reaction of normal force and reaction of frictional force. The direction of
Okay,
the
that's enough.
I have a question to ask reviewer. You mentioned about the effect of not flat surface of liquid, such as sine function. In such case, would that affect some of the result, and how?
First of all, I mentioned another possibility of modeling the water surface because I think that would have an effect on calculating the center of mass of the liquid. And therefore, I thought it would have an effect on their prediction of their model.
But the presenter, he rated the average and they calculate the center of mass also in such case. And do you think of any other effect?
Other than the prediction of center of mass.
Other than your answer.
I think the center of mass would be the critical factor in the rocking motion, and therefore the effect on the center of mass would be the most relevant.
And I have a question to the presenter. How did you measure the acceleration? How did you actually measure?
So I showed the video of the rocking bottle at the observation stage. And I used the Lower Pro program to trace the red dot I attached at the center of the bottle.
I have a question to reporter, and I think your model, the theoretical model, is a good improvement from the simple harmonic motion.
Yes.
And I think that was possible because you considered the motion of the liquid.
Yes.
And I guess, in your equation, to consider the motion of the liquid, you inserted the viscous force
Viscous force. Yes.
of the liquid, right?
Yes.
And in that the viscous force, the D, you use symbol D to measure the thickness of the liquid, right? And did you actually use that experimental measurement of that thickness into your theoretical equation to predict the data?
So, can I answer this question?
Yes.
So I admit there was limitation for measurement because, like, I cannot actually see the flow of the water inside. However, I measured this imaginary thickness by observing many particles, as many particles as I could. So up a certain line, the motion of the glycerin powder is quite irrelevant to the relative motion of the bottle as the bottle is rotating. However, down a certain line, the glycerin powder starts to accelerate to the direction of the rotation of the bottle, and I measured the thickness, and I admit there's a large standard deviation of the beta. However, the imaginary thickness was about 1 to 2 millimeters, and it changed according to the viscosity change.
Okay, my question was, did you use the constant value for the D?
So, yeah, I substituted D with the value around 1 or 2 millimeters.
Mean value. You use the mean value of
And
D.
I use the mean value at every case as the viscosity changing.
Because I thought that the value of D is, as you said, varies in time, right? Because the motion of liquid is not constant rotation, it's rocking. So the variation of D may be critical in your theoretical prediction.
The variation of the D, because the distance D will determine the frictional force of this fluid. So this is actually theoretic experimental data achieved by analyzing the video and poetry problems.
Yes,
Okay, I have a question for all three if we have time. For the opponent, one of the major things that you asked the reporter was the initial condition. Concerning that, you specifically asked why they didn't push the bottle. When you push, you give an impulse force, right? And that, with a short period of time of the impulse, would create what conditions in the liquid that his model could not predict.
Okay, so the difference, I think, between the push impact and slant, accelerating by the slant, is different for how the force is acted. So for the slant, it gets a constant acceleration and will act like an inertial coordinate and make a very fine surface. However, I believe that impact will cause more destructive formula of the surface pattern, and it will make, as the reviewer emphasized, it will make a different conditions for the experiment.
So it will make the problem harder, right?
Yes.
Okay. And for the reporter, in terms of using the incline, first of all, I have a question. How do you define your t equals 0? Because it seems like you had maximums for acceleration and velocity near 0 for some of the graphs.
Can you rephrase your question, please?
How did you define t equals 0?
T equals 0. So I define the t equals 0. So in my equation, I have the initial condition as the velocity of the liquid is actually 0, and there is when the liquid is at the maximum angular displacement. And I had a theory experimental result, and using slant did not always cause when the bottle actually reaches the horizontal surface, it did not always meant the initial angle was the maximum. But I started to measure the phenomenon when the tilted surface of the water was at the maximum angle of disposition.
Does the incline set up doesn't it set up an initial angle
Yeah.
of the liquid
So,
respective to the normal to the surface?
about the initial condition, I was kind of worried, so I conducted additional experiment. As I changed the angle of the slant, you can see here that the acceleration of the amplitude is increasing because the initial angle is increasing.
So your t equals 0 is arbitrary, kind of.
So it's not arbitrary, but I
Defined by the angle of the liquid.
defined by when the angle is at the maximum position.
And the reviewer, how much is there a difference between dynamic and kinematic viscosity, and is that beyond the error bar that they report?
Well, I mentioned the possibility of applying kinematic viscosity because the fluid inside the bottle.
I'm asking for typically water, what's the difference between the two, quantitatively? Order of magnitude, few percent, how much?
I can't. For water, there would not be a significant difference, but since they also predicted situations with viscosity, I thought it was relevant.
Would it account for the error bars?
Yes.
This is not how much you know, it's a debate, right?
Yes.
Well, there's one short question? No?
Yeah, short question, yeah. Have you thought of in your cylinder, have another cylinder? In that case, it looks like a cylindrical situation. How about, have you thought about if you have a cylinder and another cylinder inside?
So I had the case, what if there is a falling cylinder inside? So I added the falling cylinder actually inside that. So for the bad quality of the video, but I actually videoed the phenomenon when another falling cylinder, and it just showed the double peak edge with some difference because it was not liquid with volume I expected it to have, but rather a mass concentrated at the end point. So, it still shows the double peak with the maximum and minimum values.
Okay. All right, so the judges will tally up the scores. Get outside. Okay, I believe everybody's ready. The scores for the reporter team. 8, 8, 9, 9, 8, 10, 9, 7, 7, 9. And the scores for the opponent team. 8, 9, 10, 8, 9, 9, 9, 8, 7, 8. And scores for the reviewer team. 7, 8, 8, 7, 8, 9, 9, 8, 7, 7. Okay, I'd like to thank all three teams, and we'll take a